Hi guys. I wanted to talk to you about finding the area of a trapezoid. But before we do that, I want to back up a little bit. So the first shape that we have that's somewhat related to this would be a rectangle. All right, and hopefully you know that the area of a rectangle, in fact, don't tell me that you don't know this because I'll be upset. But the area of a rectangle is found by multiplying the length times the width. I'm doing them in cursive because a length L would look like a 1. So I usually do that, but sometimes people do capital L times capital W. All right, so this would be the length right here, and this would be the width, but truthfully it doesn't really matter because multiplication is commutative, so if you decide to call this the length and this the width, it won't make a difference. All right, so that one should be very familiar to you. The one that is maybe not familiar to you is another shape that's related to this. Imagine that something very heavy came along and sat on top of this rectangle, that it would probably squish a little bit, and what would happen is it would look like this, but with straighter edges. All right, this is called a parallelogram. And what that means is it's a quadrilateral having 4 sides, and both pairs of opposite sides, these two and these two, are parallel to each other. So think of train tracks when you think of a parallelogram. These two sides, just like train tracks, will never touch, and then these two sides, like train tracks, will never touch. Right, the area of a parallelogram is related to this one somewhat. We've got this, instead of calling this the length though, we're going to call it the base. And then the height of it, since it's tipped a little bit, is not the side anymore like it was in the previous one, but we're going to call it this right here. It's the one from an upper corner up here. We drop down until it hits this bottom side. All right. Don't draw it from the upper corner and draw it down here or down here. It's got to drop straight, like if you dropped a rock or something, like a pebble, it would drop straight down to the ground. It wouldn't go to the right, it wouldn't go to the left, it would go straight down here. And this little box like that means it's a right angle or an L-shaped, like that. So this is called the height. All right. So the formula for the area of a parallelogram is base times height. So very similar to our rectangle, but the difference is the height is not one of the sides of the triangle, or I'm sorry, rectangle, like it is here. It's inside of it. It's not actually a side length. So the base is the same as this, what we call our length, but the height, or what we had called the width right here, is inside, or potentially outside if you drew it right here, but it is not an actual side. All right, so there's a difference. All right, so like for example, let's say this were 8 and this were 6, we would say that the area of this rectangle would be 6 times 8, or 8 times 6, and we would get 48. And then if we had said this were inches, then we would say this were 48 inches squared, because it's 2 dimensions, length and width. Here, let's say that this were, let's say we did this 11, and let's say this height, or this height, they would be the same. Let's say that were 5. So when we went to find the area of that, we would do 11, the base, times 5, the height. Let's say this were centimeters and centimeters. We would say that we would get 55 centimeters squared. Okay, pretty easy? Okay, so then let's talk about the shape that we actually want to talk about today, which is a trapezoid. So hopefully you all know what a trapezoid is. It's kind of like a parallelogram here in that we've got parallel bases like this, except it's only now one pair of parallel bases. So when we draw a trapezoid, we draw these two parallel to each other, and then we draw this side like we would do in the parallelogram, but on this side it's no longer parallel. Right, so this is a trapezoid. All right, exactly one pair of parallel sides instead of exactly 2 pair of parallel sides like we have here in the parallelogram or in the rectangle. Sorry, I should have drawn it like this. Parallel, parallel. Okay, so in a trapezoid we only have 1 pair of parallel sides. So I just made 2 parallelograms, and hopefully this is going to work. I did practice it ahead of time. So let me just get these under here. I made a parallelogram, trapezoid, and then I made a second identical one. So I want to use these because I want you to see where this formula comes from. And let me get a little bit further away. Okay, so the area of this one and the area of this one, whatever it is going to be the same because they are identical. Again, I can put them on top of each other and you can see that they're identical. So here's what we're going to do. We're going to take, and I'm going to put them like this so that this slanted edge lines up right here, right? Now hopefully you notice that when we do that, we get a parallelogram. Right, notice that these two bases have to be parallel to each other because they already were at the beginning. But then what happens, and you're just going to have to trust me on this until you get into geometry, this edge right here, whoops, this edge right here and this edge right here are parallel. I promise you that's true. It looks like it's true just looking at this shape that we've made, but trust me that it actually is true and that this is not just like an optical illusion. All right, so what I'm going to do is I'm going to take my two trapezoids and I'm going to label them because, again, notice that the two bases, the two parallel sides are uneven. So I'm going to call this one base 1, and I'll just put B and a little 1 down there. And this I'm going to call base 2. It doesn't matter which one you call it. But I'm going to call the bottom one base 1 and the top one base 2. And then I'm going to do the same thing in this one. This one's called B2. This one's called B1. Notice I didn't switch up the order. I called the longer one base 1 here, and I called it also base 1 down here. And the shorter one I called base 2 here, and I called the same thing here. Okay, so then let's take and put them back together. And let's think about how we would find the area of this giant parallelogram, since we know how to find the area of parallelograms already. All right, well, it would be the base, all right, whatever the base is. And the base here would be base 1 plus base 2. So let's say maybe this were 6 and this were 4. The whole base together would be their sum, 6 and 4. And then let's also talk about the height. I haven't drawn that in, but the height of this trapezoid would be from this vertex, draw it down here. That line that's right there is just coincidental. I was just using scrap paper. So that is the height of the trapezoid, and it's also the height of the parallelogram. So if we're trying to find the area of this giant parallelogram, we would take base 1 plus base 2 times the height. All right, the whole long base times the height. And again, the whole long base comes from adding the long base, base 1, to the short base, base 2. All right, so let me write that down. Let me get this out of the way. So again, what we've done in our picture is we've made an identical trapezoid to go right next to it. All right. Sorry, I'm much better at drawing things ahead of time. All right, so this is called base 1 and this base 2. This is called the height. This now is base 2 and this is base 1. And again, we're assuming that you're trusting me that these are parallel. And these were parallel to begin with. So the area of this giant trapezoid, or this giant parallelogram, would be area of the giant parallelogram is the base, right? Which in this case is B1 plus B2 times the height. Again, we don't know what B1 and B2 are. The example I used was this was 6 and this was 4, so it would be 6 plus 4 is 10. But whatever their sum is the base of our giant parallelogram. And then we find the height and just multiply it by that. So base 1 plus base 2 times the height. Now, that's the giant parallelogram. That's not what we were trying to find. We were trying to find the area of our trapezoid. So I'm going to say the area of the trapezoid has to just be half of this, because remember, this is made up of two identical trapezoids. So if we're trying to just find the area of the trapezoid, we just have to take half of this. All right, so the area of a trapezoid is half of the area of the parallelogram, and the area of the parallelogram was base 1 plus base 2 times the height. Right, and again, I'm talking about this specific parallelogram. In general, we don't have a line drawn through it like this to split it up into two smaller trapezoids. All right, so the area of our trapezoid is going to come from doing half of the area that was this, the two trapezoids together. So sometimes you see it written like that. Sometimes you see it written as base 1 plus base 2 over 2 times the height. Those are pretty much the only two ways I usually see them. But I guess you could write it as the height divided by 2 times the sum of the two bases. But I would say these two are more common. Okay, I'm going to stop here, and then you get that worksheet I asked you to print out, please, the area of the trapezoids, and come back, because then we're going to work through a couple of these problems. All right, bye.